So this last video for the day is going to be a lecture type. So it doesn't follow along with any of the handouts or anything on the computer. Usually I give you a practice sheet and we'll do it in class, but since not everyone could maybe but print off the sheets that are on the computer, I just figure, you know what, I'll do it on the whiteboard and you'll just have to follow along. And you'll follow along just using a piece of paper, okay? We're not going to be able to do a ton of these, obviously, because the drawing out of the ray diagrams is going to be tricky. We will end up having, I'll come up with something where you can demonstrate how to draw a ray diagram online. Maybe we have you guys each individually show me. I'm not sure yet. But what we're going to look at, okay? So this is mirror number 1. So we're looking at the plane mirror. So this is my plane mirror, and you can see the dashes are showing you the back of the mirror, okay? So the other side is obviously the front of the mirror. We've been talking about rays of light. So how can you find where an image is going to be based on how the light acts, okay? This is where ray diagrams come in. So knowing what we know about light, and maybe you don't know what you know yet, but I will demonstrate it. You'll be able to find where the image is going to be in the mirror. Okay, that's why we're doing the ray diagrams. It's so you can locate the image. All right, so today we're doing the plane mirror, and then tomorrow we're going to look at curved mirrors, and then we're going to look at lenses. So for today, we're looking at a plane mirror. Very straightforward, okay? So we've already kind of talked about how light reacts on a plane mirror, right? You have your incident ray and your reflected ray, and the angle of incidence is always going to equal the angle of reflection, right? You got to keep that in mind for this. That's very important. So let's start by drawing an object. I wish I had thinner markers than these ones. Oh, wait a second. Maybe I do. Oh. In my pencil case. Should have grabbed some from the school. That's okay. I will use the thick ones. Oh, wait. These ones, does this work? Oh, okay. Just that's so much nicer. Okay. So I'm going to draw an object. So you guys are going to follow along and draw an object. So I'm just going to draw an arrow. Okay. There's our arrow. So that is our object in front of the mirror. Where is the image going to be in the mirror? How can we find where the image is? All right. So step number 1, you need to draw a parallel line off the top of the object that hits the mirror. And yes, this is what I'm using as my ruler. It's a kid's game. Okay. Oh, here we go. So you're going to draw parallel line. Let's pretend that one's parallel. Okay. Off the top of your, let's pretend that that came off the top of the object. Okay. Off the top of the object to the mirror. Okay. If this was a ray of light that came off the top of the object and hit the mirror, perpendicular, it would reflect back on itself. Okay. So we're going to pretend that this is our ray of light. First ray of light going off the top of the object, it would hit the mirror and it would reflect back on itself. We're going to extend this ray of light back into the mirror, because what we're doing, and just take side and just remember this right now, is every time we extend a ray of light, we always extend the reflected ray. Okay, we're always extending the reflected ray. So if this was an incident ray, it hit the mirror, and because it's perpendicular, it would reflect back. We're going to extend the reflected ray. How do you show that you're extending your reflected ray? Is by doing a dash. I think that's coming up there. Yeah, it is. Okay. It's showing, so it'd be a dashed line. Okay. It'd be a broken line. That is showing that we are extending our reflected ray. So we're going to do the same thing on the bottom of this. Okay. I got to stand up to kind of see this one. So we have an incident ray of light coming off the bottom of the object and hitting the mirror, okay? That reflected ray would bounce off the mirror and come back on itself because it's perpendicular, okay? Remember, the angle of incidence has to equal the angle of reflection. Well, we can't, for here, it's the same. The angle of incidence is 0 because you would measure it from the normal. Well, the normal is perpendicular, so our angle isn't 0. So our reflected ray will be 0 as well. It's not anywhere off of the normal because it's on the normal, okay? So we're going to extend that reflected ray behind the mirror because we always extend the reflected ray. This is not going to look super, it's getting a little closer together there, but that's no biggie, okay? So those are the 2 rays of light you do first, okay? Off the top, perpendicular to the mirror and back, and then off the bottom to the mirror and back on itself, okay? So that's 2 rays done. Now, we need to do 2 more rays to find our object over here, okay? Actually, I lied. 4 rays, but you know what? We can do it as 2, and I'll show you. I'm going to switch marker colors. I'm going to use orange now. So, second ray of light, we're going to do off the top of the object, okay? It doesn't matter which way it goes, if you do this way or if you're going to go this way. I tend to try to go out because I don't like to clog everything on in the inside here, okay? So, second ray of light is going to go off the top of the object, set an angle, okay? Here. It's going to hit the mirror. Anytime we're dealing with a plane mirror and we have an incident ray, before you do anything, well, obviously you can't do anything because you can't show the reflected ray because we don't know the angle yet. You have to draw the normal. I'm just trying not to make it too just move that a little there, just because then the shining is not so bright on that spot. So we have this incident ray of light going off the top of the arrow and hitting the mirror, okay? We've drawn the normal up from where it intercepts at the mirror. And in class, if we were in class, I'd hand you out all protractors, and you would use it to measure this angle, okay? You would find out what the measurement of this angle is. Let's say it's 37 degrees, okay? You would then therefore go and measure the other side, 37 degrees. We're just going to have to guess on this one, okay? Let's say that this is 37. Hey, you know what? I don't think it's that bad. Okay. Showing the arrows. Oh, let me just push this back for a sec just so you can see my arrows. This arrow, because you need to show the direction of the light, is coming into the mirror, and now it's going away, okay? So you always have to show the arrowheads here to show the direction of the light. Okay, we're going to say that this is also 37 degrees because angle of incidence always equals angle of reflection, okay? Now, what do we always extend? We always extend the reflected rays. This is our reflected ray, so we got to extend it back. I think that's, I'm going to cheat a little here. Hang on. So we're going to go here. So we'll kind of have the same. And we're going to extend it back. Okay? So we've extended the reflected ray back, and we always do that. And then it hits over here. Okay, so I used to teach it, and we all used to, all the teachers, we used to teach it where we do 2 rays off the top. We don't need to do that. We don't need to get carried away. You are at home. We're not in school. I think 1 is suffice to get the gist of what it is we're trying to show here. So with that being said, we are going to go over here. Okay, we're going to pick a spot off the bottom because there's 2 spots. We're going to go with this one. Okay, and we are going to do the exact same thing that we did at the top. Now we already have this light ray that comes straight perpendicular to the mirror, comes back on itself right off the bottom of the object. We extended the reflected ray, always the reflected ray. Okay, so now we need to have a light ray that comes off at an angle. So same thing that we did up top. You're going to have, you're going to have your light ray, incident ray. I'll try to use the proper terminology. Incident ray coming off the bottom of the object, hitting your mirror. Okay, wherever that line, that ray of light hits the mirror, that's where you're going to draw your normal. And your normal comes up. Okay. Kind of a little over, but that's okay. You would then use your protractor, if we were in class and you had one, to measure this angle. I say it looks more like 22 degrees. And then we know that the reflected ray will be 22 degrees as well. I say that's about right. Reflected ray, remember, drawing it so your arrow is always pointing in the direction that the light ray is traveling. We have our 22 degrees as well. And what do we always extend? We always extend the reflected rays, okay? Not the incident rays, the reflected rays. So I'm going to try to get that. I'm going to extend that back. And where these lines meet, here and here, is where our, okay, not quite our arrow, but you get the gist of it, is that is where our image would be. Okay? And that is how you would locate an image in a plane mirror using a ray diagram. This is the first of like 7. I think we're doing about 7. 2 different mirrors, 2 different lenses, but there's a couple different ways to do it depending on certain things with the mirrors and the lenses. So there's about 7 total. Okay, that's it. That's all you have to do. Now I would have you practice 2 or 3 of these, but may I suggest you trying to do this once more just to get the gist of the rays of light. So incident ray, reflected ray, always extend the reflected ray back. Okay? Incident ray, reflected ray, always extend the reflected ray back. And then where those intersect, that's where your image is. Okay, so actually, this is good to go on that real image, virtual image, okay? Real or virtual image. Sorry, my handwriting is atrocious. So real or virtual. So I did say, like, I will try to keep reiterating this to kind of help you to understand. This kind of helps a little bit. This is a plane mirror we're looking at, okay? So the image in your plane mirror is a virtual image, okay? I wasn't going to let you guys guess because you might not know and because I'm videotaping this. This is a virtual image. Why? I did mention about light rays intercepting. And when they actually intercept, that is when there is a real image. Because if you were to put a screen there, you would get an image on the screen, okay? I will show you in a video how that actually works. In class, we do it with a candle, and it's kind of neat. So you can actually project the candle object, the candle, the image of the candle onto a screen. When you have these dashed lines here, okay, those, we extended the reflected rays, right? We extended them. They're not actually there. This is a plane mirror, right? So it's not like this light ray has actually gone through the mirror and is meeting behind here, right? It is actually fully reflected off of the mirror. We are just extending the ray of light back as to where it would be, okay? Same with down here. So these are incident rays, but they're fully being reflected off of the mirror. We're just extending the ray back into the mirror to show where the image would be, okay? So these aren't actual rays of light. These dashed lines that we show when we're extending a ray of light, they're not real. This isn't real. This isn't a real ray of light. The light didn't travel through the plane mirror. Okay, we still get an image, but it's a virtual image because the ray of light is not actually meeting back there. these two extended rays of light from the reflected rays are not real. So because they're not real and they're not actually meeting, it's a virtual image. This is when you get virtual images, when the light rays don't actually meet. And we're going to show you some of the ray diagrams of some of, like, even some of the mirror. A couple of them for the mirror. The light rays actually do intercept, like these light rays, the real light rays. So the actual reflected light rays will intercept. And if you put a screen there, you would get an image on your screen. So if you put a piece of paper there, you would actually get an image on your piece of paper. Okay? Here you won't. You can't stick a piece of paper into the plane mirror anyways. But the light rays didn't actually travel through the mirror and are meeting back here. So because they're not real light rays meeting, you're not getting a real image. So that's when you get a virtual one, is when you have the extended reflected rays going back to meet each other. You'll get a virtual image, but you're not getting a real image. And I hope that kind of makes a little bit of sense. But as we go and look at the concave and convex mirrors, and then there's actual real images, and I'll try to be able to show you, that is when you get a real image, okay? Is when the light rays actually are intercepting. So they're meeting at a spot. Like this, but instead of just extending the reflected rays back into the mirror, you would actually get real light rays meeting. And that's when you get your real image. I hope that made a little bit of sense there. So try practicing, drawing out your mirror, drawing out an object, and just doing what we did here. If anything, practice will help you to understand how the light rays are working. And we are going forward and doing more of these ray diagrams. So I really do want you to understand how this one works before we move to the other ones. Okay? But that is the end of the ones for today.